Welcome everyone. I'm Setu Patel from the Transportation Business Unit at NI, and I'm here today to talk about our partnership with NOFFZ Technologies. Joining me here is Tom Magruder, General Manager of the Americas. It's good to have you, Tom.
Hey Setu, thanks. I'm happy to be here. And NOFFZ and NI have been partnering for over 5 years in the automotive radar production test space, leveraging the NI vehicle radar target simulator, along with NOFFZ's integration of additional chambers and mechatronics to make a test system ready for a production floor. One result of that partnership, the partnership has been so successful that we've expanded our capacity at NOFFZ and recently moved into a new facility that gives us the capacity to build multiple radar test systems that we've now deployed globally in over 6 different countries with our partnership with NI. Setu, I know that there's recently a new version of the VRTS that's come out. Could you tell us a little bit about that?
Yeah. So when we were designing VRTS 2.0, we wanted to create a system that could be modular and configurable to whatever test use case. So it's going to be able to be used in the validation space all the way to production to simulate objects from 300 to 300 meters at various different sizes and velocities.
And I hear that sometimes our customers need to make additional measurements on that. How does NI address that?
Yeah, so we do measurements with our VST platform. With VST2 and VST3, you're capable of testing up to 4 gigahertz of bandwidth.
Okay, great. So we recorded a demo showing one of these test systems in action, so let's cut to that now. This is the NOFFZ UTP 5065 radar target simulator production test system. So it's designed to test the typical automotive radar sensors you find in your bumper, like this one, that are used for collision avoidance, cruise control, safety features like that. The test system is made up of an anechoic chamber that's vertically configured. At the top of the anechoic chamber is an NI vehicle radar target simulator that simulates targets that will be seen by the radar sensor we're testing. At the bottom of the chamber is the loading area where an operator would place the sensor we're testing. And then it's connected to a linear slide that when we start the test, it slides the device into the chamber. When the test starts, it's on a rotational stage that will rotate the sensor through plus or minus 180 degree sweeps so that we can test how the sensor sees the target to make sure the target is arriving at the proper angle of arrival. Also, the NI VRTS generates targets of different velocity, distance, and cross-sectional area so that the sensor can tell what it's seeing. During the test, we'll compare what the sensor reads versus what the VRTS is generating, and we can use that information to calibrate the sensor and determine if it passes or fails. So when an operator is ready to start a test, he would place the device into the loading fixture, close the door, and press the blue button to start the test. So that's the NOFFZ UTP 5065 radar test system using the NOFFZ VRTS radar target generator. Thank you. So what we just saw was a demo of one of our smaller vertically oriented radar test systems. At NOFFZ, we build test systems of all different shapes and sizes, depending on our customers' needs. Sometimes the sensors can require a large distance between the sensor and the radar target simulator, and that can result in a large vertical system or a system that's horizontal and taking up significant space on the factory floor. Also, these test systems have multiple different options for the mechatronics, the motion of the DUT. We can have a simple linear actuator that rotates, or we could have a complex robot arm that moves a radar sensor through a very advanced motion profile.
Awesome. So you mentioned that floor space is a huge concern for production customers.
Yes.
So what are some new chambers that you're working on to help fix that problem?
Yeah, thank you for asking. To address the size of the chambers with the new generation of radar sensors, we're turning to a technology called compact antenna test range, which requires using a parabolic mirror in the radar chamber to shorten the distance between the sensor and the target simulator.
Awesome. Well, appreciate you walking us through that, Tom, and appreciate the time.
Yeah, thank you for having me today.